All right, this is on page 39 of your booklets. I decided to, hey, I'm going to make the key and record while I'm doing this. So here we go. So we've got triangle, two sides, an angle. I noticed that has the side is across the angle. So it's definitely an SSA scenario. I note also that this is acute because of that, right? The angle less than 90 is given. So I'm going to proceed to make my diagram. This is angle Y, which is 62 degrees. Got 36 yards across, 41 here. And so I will call this rod and string. And so remember, string is the main character in this play. So string is less than rod, of course. Therefore, I need to find the height. So I'm going to go 41 times sine of 62, right? 41 times sine of 62, that's the shortcut to finding a height. And you can use that anywhere in life. If you've got the angle and the slant, you can find the height, 36.20. And you notice that the string is still shorter than the height, not by much, but it's still not quite enough, right? So mathematically, numerically speaking, right, we need to go by that. And so since the string is less than the height, right, the height we just found is here, that is 36.2, right, it's shorter, there is no solution. Okay, can't even start to solve this thing. If you tried, right, if you drew your diagram, there's a very big chance that you would get an error at some point. You know what? Let's try that. Let's say you don't notice that it's SSA and you just go ahead and just, you know, this is Y and X, Y, Z, right? Like that, 41, 36. So the first thing you can solve for is angle Z, right? So we're going to go sine of 62. You can skip this step if you're not interested. Sine of Z is over 41, right? So I'm going to just quickly, sine of Z is, I'm just going to figure out what that is on the calculator without writing the steps, okay? That's 1.005 that keeps going. And you can tell that it's bigger, this is bigger than 0. It's going to give you an error, right? Sine inverse of 1.0, and that keeps going. So if I take the inverse of sine of my previous answer, you're going to get a domain error, right? It's not, it can't do it, right? So angle Z error, right? And hence the no solution part. So here, that's another way of knowing whether or not it's a no solution scenario. Next, ABC, you've got two sides and an angle, and that angle happens to be across one of the sides. So this is side-side angle. This is an acute scenario. So we're going to draw a diagram like this. Angle A goes here, which is 18 degrees. 305 goes there, 985 goes there. This is rod and string. And the string is definitely shorter than the rod, therefore I need to find the height. Sine of 18. So here we have it, 95 times sine of 18. That's 304.38, and we are in feet, right? And we can tell that this string is greater than the height. Therefore, two possible solutions. Okay, two possible triangles, two possible solutions because of this and this. Okay, we went through the string and the rod, and then we had to hone in on the height to determine whether or not there's even a triangle possible. And next here we've got triangle DEF, you've got F and side F and another side, so it's SSA, and this one is definitely obtuse. So all you do is one of these. We put the angle here, 131, this is angle F, and the side across from it is 1703.5. This is 1702, and we label this rod and string, and string is greater than rod, therefore one solution, one triangle. Okay, and the last one on this page, we've got a triangle. Oh, this one, two sides and an angle. This is not SSA. It's acute, all right, all of that. And look, if you were to miss that for some reason, then I'm going to go DEF, and I'm closing it because I've already therefore one solution. I should have said that right away, right? If you fill this in with information, E is 1702, and this is D is 1703.5. You notice that it's an SAS, which is cosine law, right? It's not even sine law, right? You definitely have to be in sine law territory, and specifically the SSA scenario. So that's how you do one that. That's why I check for that first. Then I determine whether it's obtuse or acute to continue my journey. And here is a bit of an exercise. Maybe you can watch me do this one and then try the one that says you try. But what you need to do here is you're given a triangle QRS, and it says determine the height of the triangle from the base QR, right? So it's kind of giving you an indication that this is QR, and we'll make Q and R be here, and this is basically 37 here. That's what angle Q is. QS, Q to S would definitely have to be here because we determined that this is QR. This is 36 centimeters. Okay, and this would be basically SR, right? If you do close it, R would be here, but in a sense, it's dangling up there. All right. So we're going to determine the height, which we know how to do, 36 times sine of 37. Okay. So here's where you're going to come up with all possible scenarios, and this is where it's testing the knowledge so far of this section, of this concept. 2167 is the height of this triangle. Okay, 2167, that has been determined. So now give a value to satisfy the following condition. The length of RS, so this string here, the string basically, right, this is the string, right? All RS's would be considered the string. So what would the length of the string have to be so that there's no possible triangle, right? No possible triangle. Well, we would definitely have to say that the string would have to be shorter than the rod, but that's going to be fulfilled anyways if you just say that RS, side RS, has to be less than 21.67 centimeters, which is the height, right? So string is in a sense less than height. If you fulfill that, so I'm basically making sure this is what is being said here, that the string RS has to be less than 21.67 in this particular case, and right, like that, you just wouldn't be able to close it. Not equal to, just less than. Next, the length of the string so that one oblique triangle is possible. One oblique. So this is where you say that RS has to be greater than or equal to the string. Okay, string is greater than rod. Okay, if you fulfill that requirement, if you just say this, then it's for sure going to give you at least like one oblique triangle, right? Exactly one. The length of RS, the string, so that two triangles are possible. Now this is a little trickier. I will allow you to state it in two ways. You can say that RS has to be less than the 36 centimeter mark, right? Because remember in our branching, when you go through that flow chart, once we find the height, right? First we determine that the string, if the string is less than the rod, we have to find the height, and then it branches off into three possible scenarios, right? So, and only one of those three scenarios that we branch into gives you the two triangles. So the first thing that must be fulfilled is that the string is shorter than the rod, and right, RS has to be greater than the height. Okay, so this is basically the two things that need to be met. So in a sense, you want something to be greater than 21.67 but smaller than 36 centimeters. So what we will do is we'll start with the smallest length, right? And RS will be greater than that, but smaller than the 36 centimeter rod. So you can say this statement, you can say that in one shot like this. So any value between this and this, right? These two, this is like the lowest and the highest possible values to make this happen. So if you pick 35, 34, 22, right? 21.68. But if you go 21.67 or less, then it wouldn't meet this criteria. Because if it's 21.67, you would have exactly one right triangle. Next, the length of RS so that there's one right triangle possible, and that's simply saying RS would have to be equal to 21.67 centimeters. String is equal to the height. So there you have it. I walked you through it. Maybe you might have tried this and what you weren't sure. Then you go for the next one here. Okay, you try the same thing again. And if you want to do some textbook work, you go for it. Okay, thank you. Hopefully this helped you.